Okay, the first part is on the experimental setup. Experimental setup, you have to know first of all how to sketch. Okay, there are two you need to know. One is you can see a conical flask with a chemical inside, then put an electronic mass balance. So how does this how does this measure reaction? Is very simple. You start the stopwatch the moment the reaction starts, and then you measure the mass at regular time interval. All right, then you will actually see the mass will drop. Okay, why the mass drop is because the reaction must have a gas produced. Take note, these two setups are only useful to measure rate if there's a gas product. If there's no gas produced, these two setups are useless. Okay, so must have gas produced. So during the reaction, what happens is when the gas is produced, it will actually escape from the flask. So the mass of the gas will not be captured. So you will record the mass of the content in the flask keep dropping. Right, so by measuring the gradient of the graph, we can actually measure the rate of reaction, the speed at which the reaction takes place, because the gradient is actually the mass decrease due to the gas produced escaping per unit time. Okay, rate is always, x-axis is always time, y-axis can be anything, but x-axis is always time. All right, this one, a few things you have to take note. If they give you chemical, you have to label what chemical. And then the stopwatch, some school will ask you to draw. So if your school needs to draw stopwatch, go and draw a stopwatch. Okay, the cotton wool at the top, okay, if they draw, whether you draw or don't draw is okay, but sometimes if they give you, they may ask for the reason. The purpose of the cotton wool is to prevent acid spray. What's acid spray? Because sometimes in acid reaction, the reaction is very vigorous, so the acid may get spread out. Okay, we don't want the acid to get spread out, because if the acid spread out, the mass of the acid will also not be captured. Then your mass decrease will not be accurate, because we only want the mass drop due to the gas escaping. We don't want the mass decrease because some acid gets spread out. Then it's not because of the reaction, that one. Okay, so the cotton wool there is when the acid gets spread out, it actually will get captured onto the cotton wool, so the mass will still be able to capture. But cotton wool is porous, so the gas will still be able to come out. So the gas will still be able to escape. Cotton wool cannot prevent the gas from escaping, and we don't want to prevent the gas from escaping. We want the gas to escape. If the gas don't escape, you cannot get the drop. Then you cannot measure the gradient. You cannot measure the rate. Okay, because the gradient is the rate of the reaction. Okay, especially the starting gradient. Okay, so this one is the corresponding graph of mass of content in the flask against time. Okay, the gradient corresponds to the rate just now mentioned. So when you find gradient, it's actually finding the rate. If your gradient is less steep, it means it's slower. Okay, if your gradient is steeper, it's faster. That's how you determine which reaction is slower or faster. Okay, faster means steeper gradient means the larger drop in the mass per unit time due to more gas produced. Okay, at the same time. The other one is more direct. The other one is you have a conical flask with a rubber stopper. It's rubber stopper. It's not cotton. So the rubber stopper will channel the gas into the evacuate tube into the gas stream. The gas stream initially will be at 0. So once the gas go in, you push the gas stream. Then same thing, you will measure what's the volume of gas collected at fixed interval of time. Like 10 seconds, what's the volume? 20 seconds, what's the volume? Then you'll be able to plot the graph of the volume of gas against time. So same thing, the gradient will give you the rate of the reaction. So if the gradient is steeper, it means faster. If the gradient is slower, it means more gentle, it means slower. Okay, then of course you have to label the chemical if they give you. So you have to know how to sketch. Okay, you have to know the corresponding graph, and then you have to know how to see which graph represents faster or slower reaction. Okay, that's for the first part. Okay, and take note, the drop in mass is due to the gas escaping. Okay, that one make sure you know. Right, the second part, I think about page 3 of your notes is on explaining why the rate of reaction graph is like this. Okay, so rate of reaction graph got 3 stages. First, you have to know the initial rate. Initial rate means the rate at the time equal to 0. Means the moment the reaction starts, the initial rate is the highest if all other conditions stay the same. Why initial rate is the highest? Because the solution, the reactants not being used yet, is fresh. So it will just started to react. So things like concentration of solution will be the highest. Things like solid, the surface area is the largest at the start. Right? So they will react very fast at the start. Second point, the rate always decrease over time. Okay, if no other condition change. Why? You can see from the graph, the gradient steepest at the start. Then it keep become more and more gentle as the graph change, because it's this concave kind of graph. So when the gradient decrease over time, it means the rate is actually decreasing over time. Why the rate decrease over time? Reason is because the reactants are being used up over time, right? So if it's solution-wise, as you get used up, the concentration will drop, right? If it's solid, you get used up, it becomes smaller, the surface area will decrease. So all this will cause the reaction to slow down, okay? So the rate will decrease. Third is when you get the horizontal line. Horizontal line means what? Horizontal line means gradient is equal to 0. And gradient equal to 0 means rate is equal to 0, because gradient is rate. So when your rate equal to 0, it means what? Reaction has stopped. By the way, there's no such thing as constant rate. So to go and write constant rate. Rate equal to 0 means the reaction has stopped. No more reaction. Why no more reaction? Because the most common reason is limiting reactant being used up. Okay, remember, if you have 2 or more reactant, one of them used up, the reaction will stop. So we learn that in more, limiting reactant used up. Okay. If certain question they tell you which one is limiting, you have to directly say which one is used up. Okay, you cannot just say limiting reactant used up. Okay. Right. So until here, okay. Jerome.
Take a picture. Give me a